Welcome to this tutorial on 8085 programming. Today we are going to talk about direct and indirect addressing modes. Let us understand what addressing mode is. The way in which data address is mentioned inside the instruction is called its addressing mode. Say for example, if we talk about the direct addressing mode, if the address is directly mentioned in the instruction, it is called the direct addressing mode. Say for example, we take LDA C100. This means that the data in memory address C100 is to be copied in register A. Now the address C100 is a part of this instruction and therefore it is direct addressing mode. Contrary to this, if the address is not directly mentioned in the instruction, then it is called the indirect addressing mode. Say for example, we talk about MOV A, M. Move the content of memory to A. Which content? The content of memory whose address is pointed by HL pair. The HL register acts as a pointer to the memory and the data from memory is brought into register A. So here there is no direct mention of address inside the instruction. It is understood that the HL pair points to the memory and therefore this becomes indirect addressing mode. Now let us understand this more clearly with the help of an example. Let us go back to the simulator. Here we take an example of adding 4 numbers given in consecutive memory locations and generating the result. Let us assume that 4 numbers are placed in 2000, say 23, 2001, 45, 2002, 68, 2003, A3. These are the 4 numbers which are put inside the memory. Our program should add these 4 numbers. So let us attempt it first with the direct addressing mode. So we have LDA 2000. MOV B, A, LDA 2001, add B, MOV B, A, LDA 2002, add B, MOV B, A, LDA 2003, add B, and then halt. So this will bring the first number in the processor, move it in register B, bring the second number in processor, add it with B, move the result to B, bring the third number, add it with B, move the result to B, bring the fourth number and add. So this program will add these numbers. Let us compile it. And then stepwise let us execute it. So bring the first number 23 comes to A, move A to B, second number 45 comes to A, both of them are added, so it is the result is 6A. The result is moved to B, bring new number, that is 68, to A, add, so it is D0, move D0 to B, bring the new number A3 and add. So the result is 73. You can see here that this is the last instruction of our program, and it goes up to 1012. So we have written down this program in direct addressing mode. Okay, so now let us write this program using the indirect addressing mode. The first instruction is to load the value of the memory from which the data is to be brought into register. So let us write down the address LXI H, 2000 hex. Move A, M. Move the content of memory to A, whose address is in HL. Then increase the value of HL, INX H. So originally it was 2000. Now when you increase it, it will become 2001. So first it was pointing over here, now it is pointing at this point. So again, now we need to add this number to register A. Now 8085 has a direct instruction which can do this. Add M. Add the content of memory to register A, whose value is in HL, and put the result in register A. Again INX H, add M, INX H, add M, and then halt. So every time we increase the value of HL and add the value to register A. So let us put down our original values. It was 23, it was 45, and then 68, and then A3, suppose. So let us compile this program. It's compiled successfully, and you find that the last instruction now is 0A. Previously it was somewhere over here, so many more bytes were required. So in terms of the consumption of memory bytes, this program is more efficient. Now let us see how it operates. Execute the first instruction. So HL gets the value of this memory location 2000. Next step, move the content of memory to A, whose value is in HL. So that is what we have. 23 comes to A. Next instruction, increase the value of HL. So that is increased 2001. Next instruction, add 45 to this value and place the result in A. So that happens, right? Next instruction, increase the value, add, increase the value, add, and that is the result. So you get the final result over here. So you find that the same program, by using indirect addressing mode, becomes more efficient, and at the same time, once you have loaded the value of your memory address in HL, it is always there in HL. You can manipulate it, you can increase it, decrease it, whatever you like. And this can be done under program control, and therefore this becomes more efficient. Hope you have enjoyed the tutorial. Thanks for hearing.